Okay, this is the second plenary session of the morning. We started the morning with a talk on unstructured innovation. We are now experiencing unstructured panel creation, plenary session creation. By unstructured, I mean I am not sure if all the speakers are here. David, you're here. Where is David? You're here. Oh, okay, okay. I have a black and white picture. Sorry, I cannot. Okay, Oren, I know is here. Yoav, also fantastic. Professor Hossam. Hi. Oh, okay. That's why I recognized you. Okay. And Yossi Vardi is not here, but he is probably arriving mid-session. Okay. In the morning, we had the speakers agree to give a shorter version of the prepared version so that it allowed for some discussion. Given that there are 5 speakers, I don't think we can do it in this session. So we have to finish at 1 o'clock. David, you are the first speaker. He's the director of the Laboratory of Israeli Genetics. He's from the Department of Human Molecular Genetics and Biochemistry at Tel Aviv University. Thank you.
Thank you. My talk is going to be, I'm afraid, a bit different from the rest, but I hope that many of you will be able to follow. But please stop and ask questions if you cannot. Okay. What I want to present to you is a method that we developed for personalized medicine. Personalized medicine means finding biomarkers for adjusting drug treatment in the optimal way for the individual patient. And this is one of the greatest challenges facing medicine. And this was the great hope of the Human Genome Project, that once we have the full human genome sequence, we will be able to tailor drugs and to choose the best drug for each patient. Now it's 10 years after the conclusion of the Human Genome Project. It's not yet happening. Maybe you'll understand some of the reasons when I show the data. It's happening a bit in oncology. So in oncology, for certain kinds of cancer, we have now personalized medicine, where the doctors look at certain biomarkers in the patient genome or in the tumor genome and adjust the drug treatment accordingly. But in other areas of medicine, it's not happening yet. What I will present is a technology that we developed in my lab that is used for finding biomarkers for many drugs and with relatively simple means based on a collection of cell lines that we have in the lab. So as I go along, you'll understand better. Let me also say that anyone who cannot follow can write me. I can share the presentation and the papers. We have 3 published papers already about this technique that I can share with you. The last 2 are open access, so you can access them yourself if you put it on the web. So the example that I'm going to give is the main project in my lab right now, and that's looking for biomarkers for treating depression. This is a big challenge for medicine. First of all, depression is one of the most common human diseases. The lifetime estimates that someone will be clinically depressed, meaning deep depression, clinical depression, where the person cannot work, is 10 to 20% for lifetime occurrence. And the World Health Organization estimates that in a matter of another 8 years, the cost for society for treating depression will bypass the cost of cancer, which now tops the list. Now it's cancer, followed by cardiovascular drugs, and depression is 3rd place, so it's going to bypass the other 2 and be the first issue on which societies have to spend their healthcare budgets. So the most common drugs for treating depression are known in the clinic as SSRI drugs. It stands for selective serotonin reuptake inhibitors. They inhibit the reuptake of serotonin to the synapse, and by this way increase the availability of serotonin for stimulus. And it's not clearly understood how it's happening, but somehow it helps to relieve depression, but it's a process that takes several weeks. Apparently, it's related to building new synapses, which takes time, so it takes several weeks. And the most famous one is Prozac, and all the other drugs are called Prozac-like drugs, and the most known as paroxetine. In Israel, the brand name is Roxat, and citalopram, sold as Cipralex, and there are several others. So those are the first-line treatment. In most clinical centers in the world, the first drug treatment will be an SSRI drug, one of the drugs from this family. But there are three other drug classes for treating depression. These are the SNRI, drugs such as venlafaxine, known as Effexor, or the first-generation antidepressants, those that were developed already in the 50s, such as imipramine, amitriptyline. Today they are less popular because they have more side effects, but in some patients they have better efficacy than the SSRI. They are reserved in the clinic mostly for treating chronic pain, like in diabetes, and less so in depression. But like I said, for some people, they would be better than SSRI. And then there are the serotonin ligands, such as mirtazapine and buspirone, that are also antidepressants. And for some people, they will work better than the others. But we have no way of knowing which patient will respond best to which drug. So it's all a matter of trial and error in the treating of depression. And these trials take, each round of treating with another drug takes 3 to 4 weeks to find out if it works or not. And meanwhile, there's suffering for the patient, there's lost work, and there's the big risk of suicide, that is the major risk of depression. So there's an urgent need for biomarkers to find out who will respond to which class of drugs and adjusting the best drug to the patient. So obviously people knew about this long ago, and a lot of efforts have been made, and the landmark papers, the best important study on this topic appeared already 14 years ago by a group from Italy that reported that a genetic polymorphism, that means a change in the sequence of letters in the promoter region. Promoter is the region of the gene that dictates how much of the gene will be expressed. Okay? In the promoter of the serotonin transporter, the gene that codes for the protein that takes serotonin from the synapse and takes it back to the cell, and this is the drug target of the SSRIs. So a polymorphism in this gene is related to response to SSRI drugs. So this was a big thing in personalized medicine. It was seen as a great discovery. Many groups were able to reproduce it, which looked nice at first. But then if we look now, 14 years later, recently a meta-analysis was published. There were hundreds of studies already. And what we learned was that there was a big publication bias, what we call in science. Okay? Many people who could reproduce it published. Those who could not did not publish. And only after a few years, as more data accumulated, people published also negative results. And the meta-analysis conclusion is that this polymorphism cannot predict the response to SSRI drugs. So it did not work. And many millions of dollars were spent on these studies. So people realized they had to do it in another way. What we call in biology the genome-wide studies, instead of the gene target hypothesis, focusing on the gene that is of interest. So not using any hypothesis and just looking at the entire genome, at the variation, the natural variation of human beings. And this is done with what is called the SNP array. SNP stands for single nucleotide polymorphism. There are about 15 million of them in the human genome that are already known, but there are probably close to 3 billion of them because we have 3 billion letters in our genome. And for each letter, if you put something else, another letter, it will be a SNP. If it is not lethal, it will lead to a human being that is different and has something that nobody else has. And certainly the combinations of these many millions of SNPs are endless. There are many more combinations than the number of people that ever lived. So each of us is unique, unless he or she has an identical twin. So a group from Europe received a European grant that was about 5 million euro to look into this, and they reported several genes that you can see in this paper, but it doesn't matter what they found, because at the same time, in the USA, the NIH gave money to an American group of researchers who did use the same approach, looking at SNPs, at millions of SNPs on the human genome, trying to find out what makes them respond with good response or not respond to SSRI antidepressants, and they came up with an entirely different list of genes. If you look at the list of the genes in the paper, and these are long lists with few tens of genes, there's no single match between the two studies, and each study cost many millions of dollars or euro. There's also a third study that I don't show you, but the conclusion from a review that was recently published is that if you look at common SNPs, you cannot find something relevant for what you're looking for, because the human variation is so huge that just looking at the most common SNPs, which is what is on those commercial arrays, about 1/2 million to 1 million SNPs, that's not enough. Because there are many millions of SNPs that we don't even know yet, because they were never reported. So when we started to think about this study, our idea, and I can take the credit, my creativity here was to introduce another concept. Instead of looking at SNPs, which everyone in the world around us was doing, to look at gene expression levels. We now know that we have about 30,000 genes. So this number is 1,000-fold or million-fold smaller than the number of SNPs in the genome. So it's much easier to look at a smaller number of variables. Instead of looking at SNPs and compare human beings, look at gene expression levels in the cells. And I will explain more in the next few slides, but the idea was that we had anyway in my lab a collection of about 2,000 cell lines that represent 2,000 Israelis. Each of them different, each of them unique with a different sequence that we do not know. But the idea was to look at the expression level of genes in those cell lines that start with white blood cells that are immortalized in the lab with a virus, and we keep them in liquid nitrogen and can take them out and grow them and test the response to drugs. And look for the extreme phenotypes, look for the cells from those people that respond very strongly or very weakly to a drug in vitro. And the response that we were looking at was inhibition of cell growth. Now, if you'll put any drug on a cell and increase the concentration, at some concentration it will interfere with cell growth because it's not something that the cell is used to see in the body. It's something unnatural, and it needs to spend energy to pump it out and so on. So any drug can work with this concept. Our idea was to look for the extreme phenotypes, very sensitive and very insensitive cell lines, and compare what is called in biology the transcriptome, the whole repertoire of genes and the level of expression in these cells. And I'll try to move a bit faster so we'll have time for questions. So the cells that we have in our biobank, which is the National Biobank of Israel, are lymphoblastoid cell lines that are immortalized. If each of you want to be immortal, you can give me a blood sample of 5 milliliters, and I can prepare a cell line from you that will represent your genome. Maybe you can be cloned sometime in the future. Okay, it will be kept in liquid nitrogen. It can be kept for thousands of years, probably. Like, some people now are thinking about recreating the mammoths and other extinct animals. So it's possible to do those things. So they're immortalized with the Epstein-Barr virus, and this makes them immortal. It's important to remember that the virus doesn't change anything in the genome of the host cell. So the cells still represent the original genome of the donor. A few words about our lab. It's called National Laboratory for the Genetics of Israeli Population because it was established by the National Academy of Sciences in Israel. And the idea was to have a reference for all the ethnic groups because we are a migrant society. And let's say you are studying some monogenic disorder like cystic fibrosis. You want to know all the possible mutations in each of the ethnic groups. And the mutations would be different. It would be different in Ashkenazi Jews or Yemenite Jews or Arabs or Druze communities, etc. So this was the original reason for making this lab. But then there were some other studies that are possible to do with it. And this is just a nice example. This is a famous study that actually was done at the Technion, and I'm just one of 20 co-authors here. And this was publishing the genome-wide structure of the Jewish people and showing that all Jewish communities have an origin in the Middle East and are very close to the Palestinians and other communities in the region, including the Ashkenazi Jews. Some of you may know, some historians claim the Ashkenazi Jews represent some Asian tribes that migrated to Europe and converted to Judaism, so that's not the case. This study shows that all Jews are descendants of people from the Middle East. Okay, going back to our project, we knew that lymphocytes and lymphoblastoid cell lines that are made from them express the serotonin transporter. That's an important point because if the drug target is not expressed by these cell lines, then you cannot use them as a tool to look for biomarkers. So this is something we published 8 years ago, and we're confident that the drug target is expressed functionally by these cells. If you measure serotonin uptake, you can measure it with these cells. The cells look like this, small round cells, and they like to attach to each other in clumps that easily dissolve if you pipette them, and the groin suspension. That's my time? Okay, so I'll just rush then. I think I have about 7 minutes. Okay, so I'll go quickly and then you can look at my slides. Whoever wants them can get them. We know that about 5,000 human genes are co-expressed in lymphocytes in the brain. So it's not irrational to look at blood cells while asking a question about a disease in the brain. And I'll just rush over the technique, which is very simple and straightforward and done automatically with machines that we have in the lab. I'll just show you what we found. So here you see about 20 cell lines out of 80 that we checked. Each of them represent another human being, another individual, and we look at the sensitivity to paroxetine. You can see on the left side a group of cells that are less sensitive to growth inhibition by paroxetine. Sorry, more sensitive, and on the right side, cells where you see less growth inhibition. And we compared the transcriptome of those two edges, and this is done with arrays that look like this. These are very small things that on about square of centimeter that you have here, you have probes for the 30,000 genes, and this is read with a laser machine that looks at the probes, and you can measure the expression level of each of the 30,000 human genes. And this is then analyzed with bioinformatic tools. And what we got from the experiment that we did, just comparing just 7 people from each group. So we had only 14 people represented in this study compared to many hundreds in the studies that I showed early on. We found a list of 61 genes that by criteria for genome-wide studies are significantly differently expressed in the two groups. And the top gene is something that was never suspected in the context of any neurological or psychiatric disease. It's called CHL1. Doesn't matter what it stands for. What it matters is that it shows a huge difference, 36-fold, between the two groups of cell lines. This is here a logarithmic scale, so it's a huge difference. And we already knew from a study from another group that if you silence this gene in mice, what is called knockout mice, you get wrong wiring from the thalamus in the brain to the cortex. Instead of neurons going from the thalamus to the prefrontal cortex, they go to the visual cortex. And this is the pathway that controls emotions. So we knew that something about this gene is very important for targeting neurons that play a role in the emotion feelings. And I'll conclude soon, okay? So just to show you, so about a year ago we published this study and we were confident enough about this gene, so we put it in the title of the paper, even though the whole list is 61 genes, but this is our top candidate, CHL1. And already 3 or 4 months later, we had our first citation by a clinical study. And this is an American study, which was a follow-up of what I showed earlier, in which they looked not at efficacy, but at side effects of SSRI drugs. And CHL1, a SNP in CHL1, was reported as one of 5 SNPs that they found as related to adverse events of using SSRI drugs. So with a very simple technique that cost us about 60,000 euro to run these experiments, we found something that was later soon confirmed probably as true by another group who had a budget of few millions and cohorts of more than 1,000 patients, 1,400 patients with clinical depression. It must have cost a lot of money to collect and analyze the genomes with the SNP analysis. So we are very confident that we have some good leading biomarker. I'll skip this one. This is related to microRNA. I don't have time to explain it. But we confirmed it with microRNA experiments that are another way to look at the same issue of gene expression levels. And with our preliminary data, because these data that I present here are still preliminary because they represent cell lines that are grown in vitro. I don't know anything about these people more than their ethnic group and their age and sex. I don't know if they ever had a depression and so on. So now we need clinical studies. And this is ongoing with European money that we received for this aim. And 3 groups in Italy, Poland, and Germany are collecting patients with depression, following up on the response to SSRI drugs, and looking at the relevant genes that we found with these preliminary studies in my lab. So the conclusions of the technique that I want to show you is that we have a very simple and inexpensive tool for preliminary studies on personalized medicine. If you want to find biomarkers, you don't need to collect huge cohorts of patients as a first step, which takes a lot of money. You can do things with collections of cell lines that are available in almost each country. I recently visited South Korea. They have a biobank with 500,000 Koreans. We have only 2,000. So the Korean government invested $200 million in creating the Korean biobank. They have 500,000 Koreans represented there. So you can start with requesting samples from biobank. You pay very little to get them, and you can do studies just with healthy people or people that you don't know about the disease and find tentative candidate biomarkers, and then you proceed to clinical samples, which are much more expensive and time-consuming to collect. And lastly, I have to acknowledge my colleagues. Of course, this is collaborative work of many people, including in bioinformatics, my students, and European colleagues who are working on it. So thank you very much. So questions will be at the end, right? At the end of the panel.
There is a question.
Is there an urgent question? And of course, I'm open for collaboration. That was the idea for coming here.
Yes.
If anyone has an idea for collaboration.
I will surprise you. When I was at the Weizmann Institute in the Department of Mathematics, we did a study with Batsheva Boneh, which led to 2 publications in the American Journal of Human Genetics in 1979. At that time, we had just a frequency of, we had 33 biomarkers, blood types, enzymes, and the first study of the Jewish population structure was in these papers. It attracted lots of people in terms of citation, some with a scientific orientation and some with Kabbalistic orientation, and it was quite interesting. Anyhow, it raised my citation score very high. Thank you very much. Okay. Our next speaker is Oren Zuckerman. Dr. Zuckerman will be speaking about the IDC Media Innovation Lab. I thought that what we had is very innovative, because in his bio there are 3 words, bio to come, 3 dots. So please, Dr. Zuckerman.
So hi everyone. I founded a place at IDC, at the Interdisciplinary Center in Herzliya called the Media Innovation Lab. And prior to that, I completed my master and PhD at MIT at the Media Lab there. And I want to just give you a few glimpses of how I think about what's going on in the internet era today, and then show you a little glimpse of our work, and then I'll happy to continue with discussion. So Time Magazine already in 2007 was very brilliant to identify all of us as a person of the year, and really didn't predict, because it already was visible, but was one of the major traditional media outlets that identified the major revolution. When we look at the big platforms that created this revolution, it's all completely used today. It's all very clear to us how they really transformed the media and information age, how people use it in a creative way, and how it changes not only the communication, but also governance, and other events that all of us are familiar with. I wanted to show just one quick example. I'm going to show a few videos all along this. One of an amazing Israeli innovation, a person called
what can I do?
Qutiel, that probably some of you know, but the way that he is using YouTube in a very innovative way is, for me, as an amazing way to show what is radical innovation on top of traditional, new media platforms. So as you can see, what he's doing here is taking pieces of videos that are already on YouTube, meshing them, merging them in a new way, but it's not just another interesting or nice video, it's new music.
One guitar part. There'll be somebody playing single notes, somebody playing chords, and they'll mix them together.
Okay. And let's just pick the mother of all funk chords. Let's pick a 9th chord.
So for me, that's a brilliant example of seeing how to use existing platform, but take it to the next level. I think that right now we're at a stage that another platform is doing the same revolution, but I think taking it really to the next level. So adding to these amazing platforms of crowdsourcing, of allowing user participation, Kickstarter would be my bet for the biggest product or innovations that really influence the next 5 years. Not only the communication era, but also funding, which is the biggest barrier to innovation. Any person with an idea, can be good or bad, can upload their idea and proposal to Kickstarter and hopefully get funds. All of the innovation funding industry is changing because of that. I want to show you again one example of a product that shows the radical ability of people to raise money.
My name is Claire,
Oops, sorry.
and I would like to talk to you about a very special project I've developed. As I'm speaking to you right now, I am actually using it. Kickstarter meets Botiful.
So she created this prototype called Botiful.
Botiful is the first mobile robot that you can control via Skype. It connects to your Android phone with Bluetooth or with a USB cable. It can move around and orient the head to look at what you want to see. Botiful is a moving accessory for your Skype call, and it's going to change the way you communicate with distant people.
So I think this video is a typical video from my point of view of showing us the culture of Kickstarters, how in a very authentic way, people that are builders, that are creators, they just want to invent something because they think it's meaningful, uploading it. She raised $90,000 to take her prototype to the next level, and she's working on it right now. It's another example for what I'm going to talk about throughout my presentation, which is a merging of the digital and physical world, which is a big theme of our lab. And that's one example which I think is going to be the booming innovation products that we're going to see in the next 5 years of taking mobile phones to the next level. So that's about Kickstarter. Two numbers that I like to look at. Every few months I update them, so who want to guess what the numbers are? The top one is easy. Population. So the top one is the population of the globe, and the bottom one?
Cell phones?
Cell phone subscriptions, yeah. So we're almost reaching global planets that's connected. So a lot of people say, yeah, there's many people that have more than one mobile subscription, which is true. So let's take 500,000 off. Still it's amazing to see at the radical pace that mobile phones are penetrating the developed and underdeveloped countries. Of course, it's not smartphones. A lot of them are regular phones, but still the ratios of penetration, it's amazing, and it's clear that the mobile phone is one of the biggest digital revolutions that we've all seen. I look at it as a first step of a long-term process of merging between the digital and physical world. The way that we look at the world, I'm talking about Guy Hoffman and myself, we're co-director of this lab at IDC, is that, if you look at all of us as humans, we evolved in the physical world. We have 2 hands, 2 eyes, 2 ears, and we do amazing interaction with it in the physical world. The digital world developed since, let's say, the 60s, 70s, became personal computing in the era of the 80s, of the Macintosh and personal computings. We turned to the mobility era in around 2000 right now. And the next big revolution is going to be the merging of the physical and digital, and mobile penetration, mobile sensors, like the product we saw right now, but many, many others are going to be the beginning of it. And slowly after, we're going to see more and more physical devices that connect to the network, and we can interact with them in many, many new and different ways. So as a place I did my PhD at MIT really influenced me deeply, and that's what caused me to come to Israel and do the activity I do right now. One of the sentences that guided us as students at MIT was the best way to predict the future is to invent it, by Alan Kay and other amazing inventors that is credited for creating the GUI operating systems, the Windows. He really is the person at Xerox PARC that took all our interaction with computers from the DOS text-based operating system to the Windows, and later on Steve Jobs stole it from him, and it's all history, but that's an amazing sentence that really empowers us, and that's why we came and created this lab at IDC, which we call the Media Innovation Lab. We interact with many students, many faculty members, and try to think about what could be the next steps in user experience, in user interaction between people in technology. We have faculty members from MIT, from NYU. We work with many industry partners and with many VCs and entrepreneurs. So again, we're happy to collaborate with anybody that want to think about how to merge cutting-edge technologies with cutting-edge user experiences. Our mission is, first of all, our students, to empower the students to invent and create, to bridge between academia and industry, and to try to create new models of interaction between academia and industry that will hopefully lead to radical innovations. Our focus is on two things. First, how people should interact with technology. And as I said, digital-physical interaction is a theme that's leading us. And we focus very much also on the why question and trying to think a little deeper on why do we need all of these new gadgets and new technologies and how would they meaningfully influence the world. And we call it purposeful technologies, on creating technologies that really makes a 21st century that all of us want to live in and want to see technology going in that direction. So I want to show you a few projects that were created at the lab. The lab is a collaboration between several schools, so it's a School of Communication, School of Computer Science, School of Psychology, and lately also School of Business Administration. And this is the end of year presentation. At the end of every year, we're creating this show and trying to show our products so everybody can join and just hopefully be inspired. All the students, presenters project, a lot of people from industry, from academia come over and see what's going on and what the new ideas are.
צחצוח שיניים אצל ילדים. ילדים לא אוהבים לצחצח שיניים, ולכן הפכנו את צחצוח השיניים שלהם למשחק. המשחק קוראים לו טירת השיניים, הוא בעצם מתבצע על ידי התקן שמתחבר למברשת השיניים ומשדר אותות למראה אינטראקטיבית, באופן כזה שההתקן שלנו יודע לזהות את מיקום אזור הצחצוח בפה ומשדר את המידע הזה למראה.
So this in a way, you know, their inspiration was a Wii, and yes, Wii is great for the living room and we can play and improve our physical activity. Why don't we do the same for children in the bathroom? And it's an amazing prototype which works. This project is more of an artistic, conceptual product. It's not so much a product that is aimed at, has any business aspirations.
כה יצרנו מכשיר שמודד דופק של שני משתמשים ומציג להם את הדופק שלהם בצורת גלים במים, כאשר מתי שהדופק שלהם דומה, מתחילים להתקרב אחד לשני ונוצרת איזו ויזואליזציה מאוד יפה במים. אנחנו יכולים לנצל את הטכנולוגיה כדי לתקשר עם בני אדם בצורה שונה ואחרת, בצ'אנל אחר לחלוטין.
So these were examples for two projects from this year, from 2012. I'll show you another project which is older, from 2010, that in our opinion predicted a lot of the products that we see today, of helping, motivating physical activity through technology. In this case, the students try to think about teenagers at home, on Facebook, playing Farmville, and how can we use technology to get them out of the home doing physical activity. So she's on Facebook, and suddenly she has this new banner, and the avatar is calling her to work out. So she's installing a new Facebook app. She gets into this virtual world, but she can't help the avatar unless she's going to go outside and work out in a physical way. So clearly it brings her into action. She has a smartphone, she has a relevant app on her smartphone as well, location-based, identifies her friends, and directs all of them to the park. This is our Israeli invention of the free public gyms in the park. And then she goes to the gym device that she prefers.
Great, you've arrived to the park.
And the mobile phone has a special plastic device that allows it to connect in a very specific way to the device. Now, all of you know probably that every smartphone has an accelerometer built in, and you can develop the algorithm to identify the exact motion of this smartphone. So as soon as she starts to work out,
Set, go.
the phone makes sure that she makes a complete full movement, and then the gamification system that we see everywhere in social networks takes place, and she earns points for her activity, and the points are being transferred to Facebook to give more power and more strength to her avatar online. So it's another idea for this physical-digital interaction. Another project that we did with a corporate sponsor, with General Motors. So we try to think about the passenger experience, not so much the driver experience. And as you know, most of new media or innovations today for passengers are really isolating people. So we have separated screens, separated audio systems, and in a way it seems like the vision for 21st century technologies in the car is to isolate us all. We don't need to see what's going on outside. We don't need to see who's in the car. We're all going to be immersed in a media experience. So we try to take a different approach and developed an augmented reality games that is going to motivate kids to look outside and to interact with their family members. So these kids are looking for virtual creatures. They're called Mileys, and they're hidden around somewhere in the environment. They have a special radar system that can look for these creatures. And whenever they feel that they're getting close to a creature based on the radar, so they look for it using advanced technologies. In this case, we showed what we think is going to be future technologies in the car in a year or two. They go outside of the car, they look for the creature, they catch it, and then they take it back to the car. Now, the creatures were hidden before by the parents, so the parents know where the family is going. So it can be, a trip in the weekend to see grandparents, or it can be a daily drive, to any kids' activities in the afternoon. And the kids now have to control the health of this little creature by making sure that the car is not shaking too much and hopefully motivating the parents to drive less aggressively in this case. And so it's another example of thinking how we can make purposeful technologies and not just any technologies in general. I want to show you just a last project, which is more of an inspiration for us. When we think about interaction, so mobile phones, as we said, are just the first step. We want to look at physical materials, and we try to collaborate and work with material engineers and nano devices, robotics that are very, very small and together can create new forms of materials. Just one example of an inspiring project from MIT that was developed last year of trying to think about gravity and interaction in a new way. That's from a group called the Tangible Media Group, and the project itself is called Zero N, and you'll see it in a second. So using magnetic fields that are computer controlled, both on the top and on the bottom, you can control the motion of this device, of this ball. So today there are many magnets that can easily be controlled by a computer.
Defy gravity so that we could leave them in mid-air. Zeron is a physical and digital interaction element that floats and moves in space by computer-controlled magnetic levitation.
So just creating an object floating in air is not a big deal, but creating a specific path and having the computer record this path and simulate it back is a very new idea. And thinking about this as a prototype, and think about taking it to the next level and try to think about how to simulate things in 3D, for example, or allowing people just to create structures in space can be an amazing direction. In this case, they show a conceptual application for education of showing what planetary orbits are, and you put two masses with one object and can very nicely simulate how it will behave. So that's just a glimpse of some of the projects that's done at MIT. I showed you some of our projects and some projects in general which are not from our lab. And again, I think that radical innovation with the path that we see right now happening from Kickstarter as a platform and from this huge trend and I think wish of many people to see more physical interaction is definitely going to lead to many, many new physical interactive devices in the next 5 years. Thank you.
Stop you, even though we've run over time. Our next speaker, Yoav Izar-Prato, he's the chairman of the board of Kensho, and he's going to talk about digital marketing technology. Yes? Okay, the floor is yours.
Hi, and good afternoon. I will do it in 15 minutes, maybe even less. I was actually not given with specific directions of what should be discussed, so hopefully it will cover what is expected, but I'm going to take you to a different era of this universe, which is the virtual space, and just present this company called Kensho, which we've built since 2006, and focus around the innovations. So as a snapshot, this company is 350 folks by now, working across the globe, and we tend to think that we just generate revenues for our clients. This is what we do, and using technology to do it. Speaking about the universe of Kensho, it's more about the intent side of things and the engagement. And to our humble opinion, this is search and social. It has become something substantial enough to everybody be worried about, and specifically organizations trying to build an economy. What are the areas within Kensho that we focus? It's a lot about the research. There is the technology that needs to take it to where it is. And then it's the user experience. At the end of the day, we tend to say every dollar or every euro spent should return about 9 in return. And whatever we do, we try to think whether we made it better or worse. 2006, when we started, we've been seeing all these big companies and almost decided not to do anything about it. But then 6 years later, this company called Forrester comes up with an industry layout and shows that Kensho had made a significant progress, and companies like Google, which we think the world of, has been very much lagging behind, etc. So just a couple of innovations to why Kensho has been successful, and there is a whole lot of what we've not been successful with. I'll cover those in a very short manner. There was this issue with brands that the content in the site kept changing. It became a dynamic kind of a thing versus a static kind of a thing. So whatever campaign marketer you were, you couldn't keep up with it. So we've developed this system which kind of abstracts all the fundamentals from the site, attributes them, expand them, and closes the loop between the inventory and the offering to what is presented to potential buyers. And whatever the content kept changing, it's automatically done all the way through. Trying to think whether it made worth it or worth it, it did make a lot of good for really big retailers. And then the return of investment jumped. It was much more efficient. And this is 2008 that we're talking about. Kind of being inspired with examples like that. How do you take a 30-story building and in 15 minutes build it, and it still shows and is much greater than conventional building? We decided to go into a project, which is the Kensho Editor. It's a whole offline, on desktop kind of an application. It has all these things which are important to marketeers, from navigation panes to performance data, that you can actually do something. And even when done right, all of a sudden you see companies like Tesco being 40% better as a company when it comes to the online. And hours and days had to become minutes. So it changed the whole momentum of how to actually, again, tap users. The third area is algorithms. It was pretty funny to see that folks had become fixated about it's all about bidding. We need to optimize bidding and what is my position in the internet, which is really not the issue. The issue is how to maximize the return, the incremental return, the marginal return of investment. And this is why we went into basic kind of thinking and then coding and a lot of trialing and errors of these portfolio algorithms that try to modulate how the world will act and react to different things happening, from the inventory to the demand to mobile and social medias, etc. And again, when and if done right, and it's not always the case, it has material value to those companies out there using it. Another aspect was everybody knows the internet is booming, and this enterprise notion, national level, has become congested, and at this point it's an auction-based environment in which it becomes really, really hard to get noted. And we decided to go back to this naive vision of no matter what size of a company you are and no matter what we do, we're going to give you tools to build a business, and said, all right, now we're going to take it local. And by local, we mean small, medium businesses. And therefore, created this platform that instead of having one single campaign with a lot of data, create this platform that can do a lot of campaigns with a small set of data. And kind of a crowdsourcing in the business environment to help these SMBs. It did hold value and was expanded later on to become a business unit. And the fifth is the social phenomena. We truly honestly think that with social, all of a sudden you can really represent what the human beings are when it comes to behavior, to where we spend our time and how we base our decisions. So while the world took this approach of it's one tool, let's hammer it and do something with it, no, we decided to take it apart and one by one now trying to resolve each and every issue that we feel will have value. The greatest asset after the folks that are working within the company is actually the clients. We became really good of asking questions and taking notes rather than saying this is what you need to be doing. And it is the longer route to take, but it became really substantial as a play. And 80% of the innovations in Kensho are actually out of discussions and interviews with clients, are saying to them, what is your wish list? Why? What is the value? Et cetera, et cetera. Obviously, I can't cover future innovations, but just to say that the way these things had evolved is that we recognize the power of the community, starting within the company and now being expanded slowly but surely. And ideas can be raised and tackled and voted for. And in the horizon, two specific innovations that we're going to see is we're going to see a whole dynamic era of attributing value across the information or purchasing cycle. So whenever someone does something, it doesn't matter what this something is, there is a trail, there is a path that you need to go to. And not always people are attributing the right values. From the mobile experience to the online experience to the offline experience, it's something that needs to be looked at as a whole. And the second is obviously the how do you spend your monies and how do you measure the returns. So kind of, again, to that value notion, while I was presenting in those 9 minutes probably, there was some value created. Thank you.
Okay, we are continuing with science fiction. Is this science fiction to be able to smell the existence of a disease? I'm glad to introduce Professor Hossam. He is a professor at the Technion of Chemical Engineering and Nanotechnology. He is listed on the world's top 35 young scientists, and he's associate editor of journals and advisory member of many companies and institutes. And he's going to talk to us about diagnosis of disease by breath fingerprints. Thank you.
Thank you very much for the introduction. Indeed, it started to be reality. It was science fiction. So, good afternoon. I'm very delighted to be here and to talk about one of these projects which we have led, or we have been leading in our group. Major part, I'm very happy to talk about this project in this forum because a lot of the funding of this project came from the European Commission as well as from the State of Israel. So you might see which advances we have done so far from the first time we have got the Marie Curie Excellency Grant, continuing with the ERC grant, and then with a consortium from the European Commission, which I lead since 2010. So the idea basically is to diagnose disease from exhaled breath. And when I say disease, it's a wide variety of disease. It starts from cancer, kidney disease, even neurodegenerative disease. And therefore, because the form is quite generic, I would like to escape a little bit the technical issues. I promise I will not talk about chemistry, but I will show you a little bit just to test the chemistry. And then I will show you which experience I had so far throughout my very short career. So the basic idea which we are talking about is that we have an idea, and any idea is good for innovation. However, in order to be innovative, you have to establish your idea. And the best way to establish your idea, if it is science fiction, and this is how it was introduced, you have to make a basic science. So the first step which I'm trying to convince you right now is by basic science that there is something throughout the breath which might serve as a breath fingerprint for your disease. So we believe that once a disease starts to emit to evolve in the human body, it starts to emit compounds into the blood. From the blood, these compounds have high vapor pressure, so they have to be escape from the human body. They can escape throughout the skin, throughout the urine, or throughout the breath. And of course, we have chosen for many technical reasons to focus on the breath. So they appear in the breath in very low concentrations, and if we detect them, of course, we will have a very non-invasive and inexpensive way to diagnose disease. Just to convince you, without again going into terminology in chemistry, if you take a healthy breath and cancerous breath, and you take in the signals which compounds found there, you can find that the peaks which we have here in the cancer are rather different than those healthy breath. Namely, the signature in the breath of a person with lung cancer is rather different than a healthy person. Of course, you might ask, comparing one person with the other person, this is good. However, it's not enough. Therefore, if you take a look on 65 lung cancerous people and compare them with 31 healthy people, you can see that we have two compounds which identify smokers from non-smokers. Actually, it's not that difficult. You can just smell it. It's just a scientific evidence that what we smell is exactly what we measure here. However, the most important that if you take a look on these four compounds, what you can see that we have four compounds which identify lung cancerous people but not healthy people. Namely, those could be utilized as a fingerprint, exactly as we have a fingerprint. This is a breath print, which identify lung cancerous people from healthy people throughout exhaled breath. And furthermore, we have shown throughout clinical study with real patients that lung cancer, it's not the only cancer which have a breath print. If you take a look on colorectal cancer, breast cancer, and prostate cancer, every cancer has its own breath print from exhaled breath. In other words, your breath might be utilized as a clinical sample to diagnose your disease. However, in order to do so, you have, of course, to invent a technology which can do so in very easy way, in a point of care way, and of course, and the most important, to be inexpensive. And therefore, in order to do so, in order to bring this technology from the laboratory, namely from the basic science to the technology, where you have a portable device, like, for example, just to imagine, like this device, simple for operation and easy to use and very fast instrument, you have, of course, to do a lot of developments, and this is what we have been doing since 2006. In other words, what we have been doing is to try to correlate in the same platform of this clinical device, which imitate in its operation the way dogs smell. As you know, dogs have a very good sense of smell, and many stories and actually many studies have shown that they can smell even disease. And therefore, we try to imitate the canine olfactory system by a device which we call it nano artificial nose, into which the person can exhale for a couple of minutes, and then at the end, the breath can be interacted with nano sensors, which we develop and we patented in the Technion. Once we have these interaction, signals will be emitted to algorithms, and the algorithms will analyze the results and will give us the ultimate information. To develop this project, you can either focus on one point or take the whole spectrum of the efforts and you would do it in one group. This is the reason why I have expanded from 2 people in 2006 to 17 people in my group in 2007 to 42 people today in my group who work on the same idea, but from different perspective. What we are doing in this project, we start from the basic science until the application in the clinical site. And this is something that is very important because once you do these whole efforts in one platform, in one group, you might be able to do a feedback between the different parts of the projects online and within very short time and by very cost-effective way. And therefore, in order to develop such a device, we have chosen to, of course, to make a basic science and to develop those breath prints of each disease. And then we have developed a nanotechnology and algorithms in order to detect these volatile biomarkers. At this stage, we have the so-called nose. Unfortunately, at this step, the nose doesn't smell anything. In order to teach the nose to smell, you have to train it, exactly as you train a dog. And therefore, in the lab, we start to train these devices by simulations of cancer or other disease from exhaled breath. And once you do so, you can distinguish between healthy and cancerous states, different types of cancers, and different even stages of cancer. The first grant which I have gotten from the European Commission was to develop this device, namely to develop this device until this stage. We have developed this device. We got a great success in 2008. We got more than 93% accuracy in the lab. And we had a lot of time to complete the timeline of our project in the European Commission. And therefore, I have decided that if we have enough time, I will not sit in my office. I will go rather to clinical study to try to see whether this device works. Of course, this was not in the original plan of my grant in the European Commission. And therefore, we went and we have done a collaboration with the Rambam Hospital in Haifa on lung cancerous people at the end stage of their disease, and we compare them with healthy people. This is the most extreme cases in order to validate our results. And their surprise, after we have done a clinical study, we have got an accuracy of 55%. Namely, if you flip these 5 shekels, it's 55%, 50% accuracy. Then I thought to myself, if I would develop a technology which have an accuracy of 55%, I would rely on €1 or to flip €1 or 5 shekels rather than investing many millions of euros on this project. This is the first time I failed, and this is very important to emphasize this point. We are very happy about success, and we are very sad about failures. You have to understand that failures is the best way to succeed in a very fast way. And this was indeed my case. Once we failed at the first time, I have decided strategically that from now on, I will do a clinical track. I will go with my device into the clinic, and if I succeed in the clinics, this is my guarantee for the scientific committee and technological committee that we have succeeded. Since then, we have more than 60% of my group work on the clinical study. I have to clarify one point, which was not mentioned by the introduction. I am a chemical engineer. I know very much about petroleum, and you see that I work today with the clinical study in order to really prove our efforts. And therefore, in the clinical studies, since then, we have started to make screening, diagnosis, and monitoring of disease by our device. And what I am going to show you is based on clinical study. Of course, after the first failure, we succeeded. And today, we learn a lot from this success. So in the clinical studies, we ask people to exhale into the device, and then we flow it into our device, which look rather different than nose. It's like a stainless steel box, which include nanosensors inside, namely sensors where the nanosensors are integrated within these platforms. And then we start to make the analysis of breath of people. The first clinical study, the first successful clinical study, actually was done in 2009. In this case, we have taken 40 patients with lung cancer at stage 4 and 3, namely at advanced stages of cancer, namely those people who has very low chances to survive. And then we compare them to healthy people. And as you can see, the results which were achieved from the healthy people, the whole healthy people were rather differentiated from those which were achieved from the lung cancerous people. Another way, we can argue that from exhaled breath only, by direct exhalation, we can discriminate between healthy people and lung cancerous people in a very easy way. We were very happy. We published it in Nature Nanotechnology, but the next day of the publication, I knew that these results are worthy zero, nothing. And the fact that we have identified advanced stages of cancer and I cannot help the people, means that this is nice technology, but doesn't help people. Of course, this was my second step to go into further clinical studies. And of course, we have established more than 12 collaborations worldwide, starting from Japan, throughout Europe, to the United States on lung cancer. And in this case, we have taken a heterogeneous population of lung cancerous people, starting from stage number 1, namely the early stages of the lung cancer, where we can increase the survival rate to 70%, up to the advanced stages, where, of course, the survival rate of the cancer is very low. In one of the clinical studies which was just released to the literature, we have shown in collaboration with the Denver, Colorado Lung Cancer Center, we have shown that we are able to discriminate between early stage lung cancer and advanced stage of lung cancer. The accuracy was 88%, more or less, as shown here in the table, which is very fair. Furthermore, we have shown that in contrast to CTs, which can identify a tumor but doesn't identify the type of the tumor, we can do classification throughout exhaled breath, and therefore we have shown that we are able to discriminate between benign tumors and malignant tumors from exhaled breath. Namely, we can do a work which is done usually by histology or by biopsy, which is a kind of small surgery. And of course, we were able to discriminate between different types of cancer, lung cancer, in exhaled breath. The numbers, of course, are shown here of the accuracies, which indicate that the results are quite good. Of course, there was another question whether what we are going to detect or what we are detecting is indeed lung cancer or other cancer types, and therefore we have compared between lung cancer, colorectal cancer, prostate cancer, and breast cancer from exhaled breath using the NANOS device. And as you can see, the clustering was quite discriminated from each of the other, indicating that indeed we can make different discriminations between the different cancer types from exhaled breath using the NANOS. Of course, you might see that we have missed classifications, but this is quite normal. In 2010, we have started a collaboration with the Chinese group, and we have collected 180 samples of gastric cancer, and we have compared them with other types of disease, which related to the gastric system. And as you can see here, with these 180 people, we could discriminate again gastric cancer from Helicobacter pylori, from gastritis, and other types of disease. However, in this case, please note that we have taken 75% of the samples as training, and 25% were sent to us without any identifications, and the accuracies which we have got here based on blind experiments were quite high, as could be seen here, which range from 77% to 93%, depends on what we are detecting. This approach have been expanded in collaboration with 4 big companies today, to kidney disease, for example, to Parkinson and Alzheimer and multiple sclerosis with 4 big companies. Today we have 1 company which works on establishing a device for the market of the nanos, and we have a negotiation with 2 other agencies to establish another 2 companies which can bring this basic science or lab science or translate it to the market. I wouldn't go into technical issues, but I will go to the summary. What is our vision? The small device, the prototype of the device doesn't exist yet, okay? I have to clarify it. But this is our vision at the end of the consortium which I lead, which is called LCHAOS. You can write lchaos.eu, and you can see details about this consortium. This is our vision at the end of the consortium, which have a contribution from 5 universities in Europe and 3 companies. And, of course, the vision says the following. That once the disease starts to evolve in the human body, we have volatile biomarkers which are emitted into the blood. From the blood, these volatile biomarkers exchange in the lung and appear in the exhaled breath. And what we try to find at the end of our project, this is our vision, is to find very miniaturized device which can interact the breath with the sensors. The sensors do exist today in our lab. And based on selective or cross-selective and pattern recognition methods, we make a detection of wide variety of disease. And of course, we have done a proof of concept studies, a wide variety of proof of concept studies to diagnose wide variety of disease, including cancer, kidney disease, multiple sclerosis, Alzheimer's, etc., etc. I have to mention that what I have said, that we really have proof of concepts, and right now it's our challenge to bring it or translate it to the market as a first step beyond the lab activities. We have done so far might be one of the biggest populations in Latvia, where we have taken the gastric cancer study and we have expanded to 1,700 patients, which is one of the big studies in our field. And we have similar results to the proof of concept results. These are preliminary, not published yet. Today we have another project which make diagnosis in similar way based on the so-called artificial skin. I will talk on this project in other opportunities. At the end, I would like to thank all the collaborators and, of course, the FP7 program, the LCAOS Consortium, ERC, and the Marie Curie, among the rest of the collaborations. Thank you very much for your attention.
Well, to me, it still sounds like science fiction. Okay, to introduce our final speaker, Yossi Vardi, I'm going to ask Professor Amir Shlamtak to come over. Amir is Mr. Innovation in Europe. He's behind EAI, and his impact is really outstanding. He's been a professor at the University of Trento in the last 10 years, 12 years, 15 years. I know Amir for about 30 years because of a bird. We were sitting next to each other in an Enal plane, and after reaching Cyprus, the plane had to go back because a bird crashed into the airplane engine, which gave us a lot of time to talk back and forth. So, Amir, please, and we have a small surprise for you.
Thank you for the introduction and the story about Mr. Innovation. It sounds like Mr. Muscle. But anyways, thank you. We indeed, as EAI, are trying to start innovation going or help it move along, and not only in Europe. We do see Israel as a model that I believe through the interaction that today the web and the virtual world allows can help us move ahead altogether. It is my very special and particular pleasure to introduce Mr. Yossi Vardi. Mr. Yossi Vardi is a worldwide figure, known everywhere around the world. He has helped start up 40 companies, among them the makers of ICQ Mirabilis, the Scopus and Brightco. He's a strategic advisor to Amazon AOL, a venture partner of Pitango, and I think that also one of the funds, what is it, 1.5 billion, 1.7 billion today, well known the world over. He's well known for his sense of humor. I don't know whether I should make a quote or not, but he has a portfolio is just amazing. In companies such as ICU, FoxyTunes, GDeco, companies that sold to Microsoft, Fixia, Atlas CT, which competes with Google Maps, the Freeing, that is a competitor to Gizmo Project. We are honored that we have Mr. Yossi Vardi here with us for this opportunity. The surprise is that the Innovation Academy of EAI has voted to give Mr. Vardi the Innovation Leadership Medal. This medal was jointly awarded in the past together with other bodies in Israel to people like Madeleine Albright and Dennis Ross and so on, but most related to technology. Last year we awarded this in the Rome event to Dr. Lorenzo Delai, who is the president of the province of Trentino, and recently received an honorary doctorate from University of Haifa. And today, he's been there for about 10 years. Trentino is known in Italy and in Europe as the Silicon Valley of Italy and the Innovation Hub of Italy, with the only place in Southern Europe with an EIT office. And we are honored that we have people that can lead innovation around the world in countries, whether Europe or in Israel. So again, Mr. Yossi Vardi, thank you very much.
Very nice, thank you. Thank you very much. As I always say, if my father would have been here, he would enjoy it, and if my mother would have been here, she would even believe. But I really appreciate it. Thank you very much. Also, a comment which I make always inside, along my good successes, which never been my good successes, but usually it's people with whom I had the fortune to be associate. And in many cases, they are the responsible to one. I just happen to be there. I have also a very impressive list of failures. When you are giving a medal for the record of failures, I would like to be considered again. So, and as we know, innovation, one thing come with the other. I would like to talk about two things. Number one, the revolution in innovation which took place in the last 20 years. And number two, the Israeli component of it. Until the mid-90s, and since World War II, or maybe even before, the innovation agenda of the world was grossly dictated by probably 15 chief of staffs of the big defense establishment, United States, Russia, India, etc., and number of conglomerates, like the one which is very well known is Bell Labs. You can add to it GE, General Motors, Xerox PARC really pioneered the whole new approach, and we should give a credit to a great friend of Israel, Jacob Goldman, who established it, and same in Europe and in Japan. And the whole thing was very concentrated. I didn't see numbers, but I believe that the first 100 entities probably were responsible to 80 or 90% of all the money which went into innovation. Innovation was a slow and heavy process. When somebody had an idea, he had to go through and of course I have to mention the academic institutes, which were also part of this kind of triangle: academy, large conglomerates, military establishment. They defined the agenda of innovation to a very large extent. Here and there, some private individuals were able to come with some idea, but this was not the real case. The massive, organized innovation effort was done in these places. Almost 20 years ago, something really began to change, and change in a major way, in a way that the world didn't see before. All of a sudden, millions and millions of young kids had a say, whereas in the former years, before the 90s, the military defined the size of chips, and they wanted 128 bits chips in order to calculate trajectories of intercontinental missiles. All of a sudden, the users of the Sony PlayStation were not happy anymore with 16 colors. They wanted 32,000 colors. They wanted every possible shade of green or orange or gray. And all of a sudden, they were the main driving force to the big-scale production of very sophisticated chip. The pendulum moved. They defined the agenda. I still remember that when the PlayStation 1 came out, United States government didn't allow it to be sent to Israel and other countries because it was considered for a while as a strategic device because of the computational power of the machine, and we are talking less than 20 years ago. Something else came. Something else, whereas, as I said, formerly, if you wanted to innovate something, you better go and work for Bell Labs, and then if you want a budget, you have to submit a proposal, and the proposal has to go to your boss, and from your boss to his boss, and from his boss to his boss, and it would take a very long process of approval the budget. Today, 2 kids with very inexpensive computers can sit in a kitchen or in a Starbucks and develop a whole application. The last number I saw for the Apple Store application was 750,000 applications on the Apple Store. So how this revolution happened? The revolution happened because of the appearance simultaneously of number of things which are related and unrelated. First of all, from the technology point of view, as we know, the three enablers of strong computation got down in price in an amazing way because of Moore's law and similar laws. Storage, processing, and connectivity went down in an unbelievable way. It's being manifested every day, every week. You can see what's going on now with the cellular in Israel as a proxy to the reduction in cost of communication. Broadband became available. Computing power. I saw yesterday an Android tablet, which you can buy in China for $40. $40. Now, we saw this very lovely thing, which Oren showed us, how you can embed cellular phone or tablet with all its computing power in a device. And this, of course, opened a whole new horizons for people to go and do applications which were not economic before. More than that, while only 10 years ago you couldn't start to do any real software product without investing in servers and in other equipment, today you can hook up to Amazon I'm sorry, and buy your computing resources and storage resources the way you buy electricity or water, which means that the barrier to entry is zero, no barrier to entry. The only barrier to entry is your ability to sit and write code. This is a huge revolution. This is a huge revolution, but this is not the only, thank you very much, Professor Rosenberg. But this is not the only revolution. Not less important revolution is the sociology of innovation. Bill Joy, the revered CTO of Sun Microsystems, said not too many years ago that the day that he realized that most of the smart people are outside of Sun was a very painful day for him. And what we saw in the last 10 years is a total change in the way the large companies are perceiving outside developers and outside programs, etc. While 20 years ago, if a company came with some idea, it tried to protect its turf. We remember the TRS-80, which was kind of one of the first popular computers. They didn't allow anybody to go and develop on this platform. And the result, they had very small number of games. Whereas people who came with open platforms were able to engage the wisdom and the interest and the dynamics of all these thousands and thousands and tens of thousands and hundreds of thousands of developers. So what we saw in the last 10 years is the evolvement of the platform approach, which means that the large companies began to understand that if they don't recruit the developers, the independent developers, their product will not be popular. And if you look again at what's going on in the smartphones as a proxy to this phenomena, you see that Apple is able to recruit many developers, and they have and as a result, they have a lot of offering to offer on their App Store. Same is true with Android, whereas BlackBerry and Nokia and others have to fight very hard in order to engage the developer community to come to develop applications for their machines. About 6 weeks ago, we ran here in the port of Jaffa a big event called DLD. And to this event, we had people like Facebook, Amazon, Google, IBM, Microsoft, LivePerson coming and doing events for developers. And just as an anecdote, I can tell you that I got an email from the Facebook people, and they wrote to me that the event they had in the port of Jaffa was the biggest event they had outside of the United States. And the Amazon guys wrote me an email, I showed it to, that they got panicked. They got panicked when they saw the number of registration, because in one night, 1,000 people registered to their event, which was an event for developers community to explain to them the Amazon Web Services. So you see that the largest companies in the space are courting actively the developers. And they understand that innovation today is coming from the edge, not from the center, not from the hub, it's coming from the edge. Another thing which is very important in this whole popularization of innovation is the open source approach. Whereas, again, 20 years ago, people tried to keep their innovation to themselves, today people begin to understand that in order to get the maximum value from innovation, you have to open it to other interested people, that you alone will not have the time and the resources to go and to explore and to utilize everything which is related to your innovation. But you have to enable other people to hook up to your innovation, and a whole array of tools were developed in order to enable two independent developers who don't know each other to collaborate with each other, like APIs and SDKs and web tools, etc. So today you are developing something, you are leaving some hooks that other people that you even don't know can come and develop for their own, but when they develop for their own, they are actually fostering your innovation. And this is something which were not before. You remember that AT&T, for ages, fought the legislation that nobody will be able to hook up a telephone to their system. IBM, in the 60s, used to bundle their software with their computers until the Justice Department made the unbundling move. Every time that a system was opened up, a whole industry was developed. When this Mr. Carter, who created the Carter phone, who sued AT&T because they were not willing to connect his telephone to the AT&T system, won the case, the true revolution of this device started at that time. Without it, it wouldn't be developed. So we see reduction in cost, open platforms, the platform approach, innovation which is coming from the edge, and innovation which is coming from the edge is much faster than innovation which is coming from the center. I moderated a panel in Turkey half a year ago. I had 2 startups and 2 very large telecommunication companies. And the topic of the panel was, you wake up with a great idea. What next? And it was very interesting. The large telecom company said, one of my guys came with a great idea. He had an idea how to make an antenna for cellular tower, which will be this size instead of all these monstrous things. And we were very able, we were able to develop it very quickly. I asked him how quick was quick. He said half a year. And there was a young guy who said, I had an idea, and after 2 weeks, it was on the web already getting users. So what we see today is a very interesting alliance between large companies and individual and small companies. And with the aid of internet, there are today marketplaces where you can recruit developers. So that's the scene. Now I would like to say a few words about the role of Israel in this whole place. As you probably saw, a very interesting small research group called the Startup Genome, which is in Berkeley, California, and they are watching statistics of startups. They just released the research 10 days ago, where they came to the conclusion based on statistics, not based on qualitative things, that Tel Aviv is the #1 hub after Silicon Valley, before Los Angeles, London, and Boston, which I think is very, very interesting. I was very pleased to hear it. I had very little to do with this research, but they had some points which they needed clarification, so I tried to tell them our point of view about the whole thing. And as I mentioned before, with Facebook and Amazon, Israel is becoming a pilgrimage destination for big companies who are looking for innovation. We have today in Israel the best of American and international companies present here. We have here Microsoft and Google and Yahoo and Computer Associates and EMC and Cisco and BMC and Motorola, you name it, they are here. What they are coming to do here, they are coming to look for innovation. They are coming to look for innovation because the people here are very active, very nimble, and very, very fast. The phenomena is amazing. I mentioned there's a testimonial what we had here in the port of Jaffa. We had events of each of the big companies, and all the events were full of young developers. Why is this phenomena taking place in Israel and not in other places? Again, I would like to suggest that it has to do with culture and with spirit much more than with finance or with the military. For instance, the people here are willing to dare, they are willing to venture, they are willing to take risks, they are being pushed by their friends, they see tons of role models. in the family, the culture in the family is that, yes, you should go and venture and try, and the results are quite amazing. But I would like to suggest that nothing should be taken for granted. This kind of culture, which is very important, should be nourished and supported by all kinds of facilitations to help this community of young and alert people to go and do it. We are talking about European innovation, and as we know, we always ask why we have here so much innovation and why in Europe it's a little bit more heavy, kind of slower, and this is a cultural phenomena. I think in my discussions with European entities, I think that they should put the light not only on the huge financial support programs of the EU, but also, or maybe even more, on the cultural phenomena. In Israel, we have an array of activities where developers can come and participate and meet each other and get access to the big companies. This is very important. I mentioned this event in the port. I was very proud that, number one, we were able to do 29 events, but 26 of the 29 events were open to anybody who wanted to come and show up and register without paying anything. So we had huge ecosystem which enabled people to go meet other people, discuss issues of common topic. All in all, I think that what we see today is just the beginning. Mary Meeker released 3 days ago a chart which I think everybody should look at, and this is the market share of different operating systems through the years since 75 until today. And you can see that the more open the systems, the greater is the market share of this operating system. So we are now into a society of free development, free hooking to other people, development, collaboration, APIs, the whole infrastructure is there, and we have just to go and harvest it. Before I conclude, I would like to thank again for this very lovely plaque, and I will hang it at my home, and thank you very much, and thank you for inviting me.